Good morning to all of you. Welcome you guys. Welcome you all. How we are doing, everybody? कैसे हो सभी लोग? Yes, I think we are live. First of all, do comment करके बोलिए now. Is the audio videos clear to everybody? Check करके do comment करके बोलिए now here. Am I audible? Is the audio videos clear? Do comment करके बोलिए. Right. Yeah. चलो. Let's start our discussions. Yeah. So first of all, do like and share to all your friends. Do like the session and share to all your friends. Now the greatest news to the aspirants of 2027-2028 के लिए, if your dream is to enter into IIT, then it's one of the greatest opportunity to all the 2027-28 के लिए. Now this Unacademy subscription that is just 9,999 only. Offer ends tonight. To enroll for it, you can use the code of BVREDDY. Use the code of BVREDDY and to avail this great opportunity and to join the live sessions. Now this Unacademy rank predictor is live. You can able to predict GATE 2026 का rank आप predict करेगा इससे. You can simply copy the response sheet URL and paste here. You can predict your rank. And the new batches we have started, you can have a look at now here from 13th March and onwards नया batch शुरू होने वाला. So the analog electronics is commencing and you can find the top educators team. Right. 13th March and what we started for both EC and electrical के लिए. These are the ESC 2025 rankers from Unacademy. You can have a look at now here these many ranks. So here so many rankers are there in this Unacademy. So you can see now Unacademy starter kit which is available and Unacademy Una. And there are 3 modes are there: voice mode and quiz mode and the smart summaries. And you can talk to Una according to your requirement. You can utilize this feature. And the test series is live and so we have 2 types of subscriptions we offer. Plus wala, other one is iconic. Plus में आपको क्या चीज मिलेगा? The top educators classes मिलेगा, live doubt solving and evaluated test series, structured courses and PDF मिलेगा and live quiz test. And then इसके साथ unlimited access. You can watch the classes any number of times. And iconic में personal coach मिलेगा and physical notes भी आपको मिलेगा. Right. You can book your slot according to your time convenience and you can communicate with your mentor. Let's crack it. These are the GATE 2025 rankers from Unacademy. Right. Yeah, last we have seen some problems we have seen now. As abhi humne here, so here we'll continue the remaining problems. ठीक है. Let's see how many problems we have finished. We can have a look at. Right. Take this one next problem. Yes, very good morning. Take this one. The current density in a cylindrical wire of radius r varies with the radial distance is given. The current through the section of the wire shown in the figure is. Right. The current density they given J, they ask him to find this current. How we can get the current from current density? Tell me now first of all. How we can get the current from current density? By the surface integration. So this is surface integral of what we can say, tell me now here, J into ds. Surface integral. Now J value given, so this means ds cylindrical system now. How I can write to, tell me now here, which is surface integral J value given as beta into r plus r naught whole squared into r dr d theta. Right. Yeah, you can tell me now what will be this I value. You can see now this is surface integral of beta yes into what I can say now, this is r square plus r naught square plus 2r naught into r dr d theta. So this value which is equal to, so beta which is outside, here we need to do the theta limits are 0 to pi by 6. Here 0, here this is pi by 6. And this is also, this value is pi by 6. So I can say 2 times we can write. 2 times of theta is from 0 to pi by 6. And so we have, and r limits are what, tell me now, 0 to capital R, radius. Beta outside we have multiplied with r, that is r cube plus what will be now r into r naught square plus 2r square into r naught into dr into d theta. If I integrate with the theta, first will come it as what will be now 2 beta into integral of d theta is theta na, will come pi by 6. And r integration, you tell me now, this is r power 4 by 4 plus r naught is a constant, r naught square, that is r square by 2 plus 2 into r cube r naught by 3. And you can see the limits are 0 to capital R. Now substitute the limits. Then I is equal to what element of here? Pi beta by 3 into, will come it as what element of r power 4 by 4 plus what element of here? R square r naught square by 2 plus 2 r cube r naught by 3. Now take the 3 to inside. Then I will come it as what tell me now? Pi beta into what tell me now? R power 4 by 12 plus R square R naught squared by 6 plus 2R cube R naught by yes, so this is 9. So check this option, tell me. So what the option you will get now here? Option A. Got it? Next. Find the resistance of a cube. Oh, this is Galatia. This is all these are ohms. Resistance of cube of edge is given as one side is given 60 centimeters made of a material of specific resistance is given. Yeah, tell me now. R is given as rho L by A. So that means rho cube L by. So this A is what I can say now L square. So it will come to be a rho by L. That is which is equal to rho value given as 60 into 10 power minus 8 by L value 60 into 10 power minus 2, which will come to be a 10 power minus 6 ohms. Yeah, good morning. A wire of 10 ohm long, 10 meters long has a resistance of 40 ohms. It is connected in series with a resistance box of resistance R given as 2 volts. If the potential gradient along the wire is given as this much, potential gradient that is dV by dx. Potential gradient. So they given as 0.1 into 10 power minus 3 volt by centimeters means 10 power minus 2. I can say meters we can write now. So from this, how much the dV by dx now, which is equal to 0.1 into 10 power. So we'll come it as 10 power minus 1. So this value, which will come to be a 10 power minus 2. Now it is volt per meter. And they given this as the length of this wire is 10 meters they given. From this, can you get the potential V now? That is 10 power minus 2 into what element now? 10, which will be equal to 10 power minus 1. This is the potential. Okay. Now what they given now? The wire resistance. Resistance of this wire is 40 and which is connected to a resistor of R they connected. So this is a 40 ohms and this is R is connected. And which will be at 2 volts. Now they are saying it as a this voltage across this resistor, they are saying it as this much. Now how much this V value, tell me now? This is 40 by what will get now? 40 plus R into 2. So we need to simplify this thing. Yeah, simplify kariye this value 10 power minus 1 na? 10 power minus 1 which will be equal to 80 by 40 plus R. We can cross multiply this is 10 which will be equal to 80 by 40 plus R. That means what we'll get now, 40 plus R, which will be equal to 800. Then this R value is what will be now here, 760 ohms. Next, a cylindrical metallic wire is stretched to increase its length. If the resistance of the wire is increased by 4%, then percentage of increase. When we are stretching, what happens? You tell me now, resistance proportional to what tell me now, L square. So that means what we can say now, that is delta R by R into 100. If it is less than 5% now, 2 into, we can say delta L by L into 100. This value they given 4 equal to what tell me now, 2 into delta L by L into 100. So we'll come it as what tell me now, delta L by L into 100, and which is equal to what I can say now here, 2%. Next, a conducting wire of cross-sectional area given has 3 into 10 power 23 charge carriers per meter cube. If the wire carries a current of this much, they are asking to find the drift velocity. And what is the drift velocity formula? Which will be given as, what tell me now, if we have this is I by A-N-E. I by A-N-E. Now you can see now here, N is the concentration. That is the number of charge carriers per volume. N is equal to what we can say, tell me now, I by A into VD into E. So this is N is equal to I value 24 into 10 power minus 3 by A value 10 power minus 4 into VD value, drift velocity given. Oh, drift velocity we should find here. I thought we need to find N. So this is VD value, which is equal to I value 24 into 10 power minus 3 and A value 10 power minus 4, N value 3 into 10 power 23, and then E value 1.6 into 10 power minus 19. Now you can see here how much we'll get now here, VD value from this. Now 3 and this is 8. And this value is what I now, 0.2 now. So that means how much will come if I say this as 1 by 2 into what I will now, 10 power. So it will come to be a, so this is minus 4 minus, so this value 10 power minus, so this 19, it will be 20 because of this 24. So will be a minus 1, 10 power minus 2 will come now. So that means which we can say this are 0.5 into 10 power minus 3 meters per second. A piece of copper and another germanium are cooled from room temperature to 77 degree Kelvin. The given copper is what, tell me? Copper is a good conductor. Copper is a good conductor. Copper has a positive temperature coefficient. As temperature increases, resistance value increase. As temperature increases, resistance value increases. As a temperature decreasing now, cooling now, as temperature decrease, resistance is also decrease. Now, whereas in case of a germanium, it is a semiconductor. Germanium is a semiconductor. Semiconductors will have a negative temperature coefficient. This alpha is negative. Alpha negative means as temperature increases, then this value decrease. Here the temperature decreasing now. So that's why R value increase. Now you can see the option which can satisfy. Copper के लिए decreases, germanium के लिए increases. Next, when a wire of aluminium and another wire of silicon are heated from room temperature to 80 degrees Celsius, then conductivity of aluminium increases and that of silicon decreases. No, here aluminium is a conductor. Aluminium, this is what alumina, which is a good conductor. Good conductor, these good conductors will have what element of positive temperature coefficient. For good conductors, alpha is positive. Alpha positive. Now what happens now here? Silicon heated from room temperature. Alpha increases. As temperature increases, resistance also increase. So, but here they given what element now? Aluminium, so resistance conductivity increase and that of conductivity decrease. Now resistance increase means obviously sigma value, that is alpha value decrease. Alpha value decrease, but they given galat na. Aluminium has positive temperature coefficient and silicon has negative temperature. So A is wrong, B is correct, R is correct. Next, a 100-watt tungsten light bulb has a resistance of 250 when it is turned on. When it is on state, 250, off state is 25. And the ambient room temperature, that is room temperature at 25 degrees Celsius is 25. They are asking to find what will be when the bulb is on. They are asking the temperature. That is R2 equal to what terminal? Basically R1 into 1 plus alpha into delta T. So this is when it is on 250 and when it is off, that is 25 into 1 plus alpha. They given as 4.5 into 10 power minus 3 into delta T. T2 minus T1 we should calculate. So this value 1 plus 4.5 into 10 power minus 3 into delta T, which is equal to 10. Yeah, so then delta T, which will be equal to 9 by 4.5 into 10 power minus 3. Yeah, simplify करके बोलिए what will come. Then delta T means what are we now? T2 minus T1. T1 equal to 25, which will come to be a 9. So this value 0.5 na. So this value 1000 na. No. 1000 by 0.5, which will come to be a 1 by 2, which will be a 2000. So that means T2 will come to be at 2025 degrees Celsius. Next, a wire of aluminium and a wire of germanium are cooled to temperature. This is similar to earlier. Aluminum is a good conductor. Germanium is a semiconductor. So then aluminum decrease and germanium increases. Next, the resistance between the points A and B. Yes, so you can see now it is a balanced bridge now. So then this element is dead element. So this is the balanced Wheatstone bridge. Balanced bridge. So that means what is the equivalent resistance between A and B, which is equal to R only. Next, the resistance between A and B. So here between A and B we should get. Okay, so you can see now here 3 and 3, 6. 6 and 6, 3. 3 and 3, 6. 6 and 3, that is 2. RAB equal to what element now? 3 parallel to 6, which will be a 2 ohms. Next, in the given circuit, the equivalent resistance between A and B. Equivalent resistance between A and B. So you can see now these two, which will becomes what element now? 3. And these two, which will be a 5. Next, now if I redraw this part of circuit, so you can see the circuit how it is now. And this point is A. And here they connected. This point is B. So this is what you tell me now 5. And this is 3. This is 3. And this is 8. And this is 5. Yeah, you can see now here this is A. And this point is C. And this point is D. Yeah, so it will form a bridge now. You can see now. Bridge, and this is the dead element, isn't it? So this means 5, 3, 8, 8, 8, 4. So that is RAB, which will be equal to 8 parallel to 8, which will come to be a 4 ohms. Next, equivalent resistance between A and B is 6, the value of R1. Yeah, so this is short is there now. So this is the dead element, no flow of current. Here also no flow of current. So yeah, you tell me now here RAB in this case, equivalent resistance is parallel. So this is 15 into R1 by 15 plus R1, which is 6. So 60, that is 15 R1 by 15 plus R1. So 3 2s and 3 5s. So this value 30 plus 2R1, which is equal to what element of 5R1. So that is 3R1, which is equal to 30. That is R1 equal to what element of here? 10 ohms. Next, in the resistance of each edge of the cube-shaped wire is shown in figure. And so in case of a cube, you do remember one point. So here, between these two, how many resistors are there? Only one. So do remember this is 7. 1. So between this, we have this is 9 and this is 10. Do remember. Now, how many resistors in a cube? Now, totally 12 resistors are there. So, the resistance between 1 and 7, which is 1 and 4. This point is 1 and 4, which will be equal to, this is 7R by 12. Totally 12 resistors now. 7 by 12. Next, the resistance between 1 and 8. This is a 1 and this is 8. Iska beech mein how many resistors are there? 2 are there. 2 means that is 9. That is 9 R by 12. Next, the resistance between 1 and 7. Between 1 and this is 7. How many resistors are there? 3 are there. That's why which is equal to 10 R by 12. Do remember this 3. Okay, from this we can say now they ask him to find 1, 7. 10 R by 12. That is nothing but 5 by 6. Next. 3 unequal resistances are connected in parallel. Okay. 2 of these resistors are in the ratio 1:2. The equivalent resistance of these 3 resistors are connected in parallel is 1 ohm. What is the highest resistance value among these 3? And they given another condition is what? Tell me now here. No resistance is fraction. 3 unequal resistances. So when they are connected in parallel, what will be the equivalent now? Tell me. 1 by R equivalent, which is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this value which is equal to 1. Equivalent is given 1 now. Next, what else they given now here? The ratio between 2 resistors, that is given as 1 by 2 they given. Yeah, that means R2 equal to 2R1. So if I place now, this is 1 by R1 plus 1 by 2R1 plus 1 by R3, which is equal to 1. Now you tell me now 2R1 LCM. So this is 2 plus 1, 3. So that is 3 by 2R1 plus 1 by R3, which is equal to 1. So this condition has to satisfy. Now you tell me now to satisfy this condition, we need to identify the values now. So here this is, we have one equation but we have two unknowns. It is solving is very difficult. We have to do the trial and error methods. Let us take some examples and we'll verify it. So again we have considered, so let us say R1 equal to 1. So to satisfy this condition I have taken. Then R2 value 2 na. We are just considering here. Let us verify. So then in this case, what I will get to tell me now here. So that is 3 by 2 plus what tell me now? 1 by R3, which is equal to 1. That is 1 by R3 equal to what tell me now? 1 minus 3 by 2. That is 1 by R3 will come it as what tell me now? We are getting negative. So negative so not possible na. So this is not accepted. Let's try the some other method. Akash, how we got the option D directly? आपको कोई ट्रिक है क्या इसमें? So if we consider the other trial and error, I have taken R1. If I have taken this as a 2, next, then R2 value how much now? Which will be a 4. Let's find this R3. So this is what I'll be now here 3 by 2 into this is 2 plus 1 by R3, which will come to be a 1. So that is 1 by R3, which is equal to 1 minus 3 by 4, which will come to be a what? Tell me now. 1 by 4 will come. 1 by 4. So then this R3 we are coming it as what element of 4. But they are saying this all are unequal resistances. So that means this is also not accepted now. And this is also not accepted. This is also not accepted. Why? Because all the resistors are unequal resistance they mentioned. So अगर हमने कोई दूसरा condition अगर हमने R1 which I have taken as 3 ohms, then R2 value I have taken it as a 6 obviously. Now try this thing. So that is 3 by 2 into R1 is a 3 plus 1 by R3 which is equal to 1. So that is 1 by R3 which will be equal to 1 minus 1 by 2 which is equal to 1 by 2. That means R3 value which is equal to how much now here? 2. Satisfying now, tell me. So from this what I can conclude now here, this is R1 value 3, R2 value R1 value 3, that is R2 value 6, and this R3 value which is equal to 1. So 3 unequal resistances, the ratio is between any of the two is 1:2. The highest one, this is the highest one. So this is the option. Yeah, I hope you understand this thing. Badhiya problem. Next. 5 equal resistances, each to R, are connected as shown in the figure. A battery V holds connected between A and B. Okay. Then the current through the FC is. If I bring this E2 here, then what will come? And this point is B. Here we have resistors. How many resistors are there? 5 resistors. And this point is A. This is D. And this point is C. Where is F? This point is A. A and F are same. A and F are same. Like this will come now. All are resistors equal. That is 2R only. This is 2R. This is also 2R. This is 2R. This is 2R. This is 2R. You can see now bridge. Bridge balanced now. So this means this is removed. Now here equivalent resistance is how much? R equivalent is 2R. Now how much this current will flow? You tell me now here. That is V by 2R. So up to here this current is I will go. Now they are asking, so this current we need now. So this current is equally will divide now. This current is I1 if I call. So this I1 which is equal to I by 2. So that is equal to how much now? V by 4R. Next. In the given circuit, if the potential at the point B is 24, the potential at point A is at B is 24 They are asking the potential at the point A. Now, first of all, you tell me now how much this current is passing in the circuit. You tell me now. Negative connected subtraction. So this net current, how this flow of current now here, like this will flow now, this current I, which will be equal to 36 minus 12 by 5. This value how much now here? 24 by 5. This is the current is passing. Now we need to find the potential at A. How this flow of current, you see this thing here, current will come like this. This current is what I mean, 24 by 5. So then this is positive, this is negative. Then we can say this as VA, which is minus VB, which is equal to what, tell me now? Minus of 3 into 24 by 5 minus 12. So how much this value? So this is 12 6 sevens minus 72 by 5 minus 12. That is VA minus VB, which is equal to minus 72 minus 60 by 5, which is equal to VA minus VB, which will be equal to, so this value, okay, so this value 2 and 6, 12 plus 1, 13 by 5. So how much will come? VA minus, this is 24 they given na, which will be equal to 5 minus 5 twos and 5 twos, 5 6.4. Then what is VA value? Tell me now here. Minus 26.4 plus 24. So what will come this VA value? Tell me, which will be equal to minus 2.4 volts. Got it? Next one. A current of 6 amperes enters one corner P of an equilateral triangle PQR having 3 wires of resistance 2 ohms each and leaves by the corner R as shown in figure. Find the currents I1 and I2s. What about this resistances not mentioned? Each resistance is 2 ohms. 3 wires, each one 2. This is 2, this is 2, this also 2. Now here this current is 6 is coming. So if I call about this I1 equal to, that is 2 by 6 into 6, which will be equal to 2 amperes. And what it is I2 value? Yes, that is 4. That is 4 by 6 into 6, which will be equal to 4 amps. So I1 is 2, I2 is 4. Okay, we got this I1, I2. Right. Okay. Completed. So fine. That's it for today's session. And we'll meet in the next class. Okay then. See you. Bye-bye.